Welcome to Chemistry. I am your instructor Dr. Suhas Gauri and I will be teaching B.Sc 5th semester Physical Chemistry course on Photochemistry. Here is the outline. In this lecture, I am going to cover importance of photochemistry, introduction of radiation with matter, spin multiplicity, followed by difference between thermal and photochemical processes, then the laws of photochemistry. So let's see importance of photochemistry. So the fundamental process of our planet is photochemistry. So as the word suggests, photo means it's related to photon, that is electromagnetic radiation, it's a bundle of energy as a photon. If that interact with any chemical entity or molecule, it get if it's get absorbed, it will react and it will give any other product. So that kind of study we study in photochemistry. So with the sun at the center, photochemistry has to have played a role in beginning of life. So as the evolution process happens over the period of time, so sun is the uh, key factor into the whole process because sun radiates electromagnetic radiation and that radiation is useful for photosynthesis process. So the only energy source on earth is it in its prehistoric past was solar radiation. So best example of solar radiation use of energy, so we use for photosynthesis. So it converts react water and carbon dioxide and generates oxygen and cellulose or glucose. So nature has developed mechanism over generation to harness sun radiation for all photobiological events. So here photobiological means photosynthesis and to produce food necessary for the continuation of life. So using photosynthesis, uh, electromagnetic radiation, plants synthesize glucose and oxygen. So the complex organic molecule like proteins and nucleic acid must have been created by photochemical reaction between simple gaseous molecules like methane, ammonia and carbon dioxide. So if these three get combined, then you can synthesize any kind of protein and nucleic acid. So this is the main ingredient or main component or main building block for the animal cells. So that's how uh, this photochemistry is very crucial for human life. Moving to the next point, see how radiation and matter reacting together. So, photochemistry deals with the study of chemical reaction which are caused by the absorption of light radiations. So, here light radiation means a photon. So, the only radiation which is absorbed can causes a chemical change. So, this is the basic definition of photochemistry. So, here we study uh, the chemical reaction which is caused by absorption of light radiation. So which radiation? So the radiation of light range causes a chemical change which are responsible for visible and ultraviolet regions. So UV and visible, these are the two regions where photochemistry occurs. So here the related photons should be sufficient energy which has energy h nu, and this energy is to raise the atom or the molecules from the ground electronic state to excited electronic state. so which essentially involves the promotion of electron from bonding molecular orbital to an anti-bonding molecular orbital. So the molecule, after absorption, it will go from ground state electronic state to excited electronic state. Now we will see the spin multiplicity. Spin paired. So molecules have an even number of electron in the ground state. Then it is in spin pair state. So the quantity 2s plus 1, where s is the total electron spin, is known as the spin multiplicity of a state. When the spins are paired, one is paired, the upward orientation of the electron spin is cancelled by downward orientation, so that s equal to 0. So your net s is the 0. So the upward orientation of the electron spin is cancelled by the downward orientation spin. Here the upward arrow is upward orientation of electron and downward is a downward orientation of electron. So because of this, it get cancelled out. So net result is s equal to 0. So here for upward arrow we denote S1 and for downward arrow we denote minus half. So 1 divided by half. So capital S equal to S1 plus S2. So if you make addition of these two spin state, we get 0. So that's how they calculate the spin state. Hence 2s plus 1 equal to 1. So because our s, that is spin state, is equal to 0, that's why spin multiplicity of the given state will be 1. So the molecule is 1. This is the figure shown in 3.A, B, A and C. So when upon the absorption of photon of a suitable energy h nu, one of the paired electron goes to higher energy levels. So here this is a paired electron. If you provide particular photon energy, it has to go in excited state. So that can be go in either in upward direction or in downward direction of the spin. So the spin orientation of two single electron may be either parallel or anti-parallel. So this state we call it anti-parallel and this state is in parallel state respectively. Now what happened to the state of the spins? So if spins are parallel, then your S value comes equal to 1. So plus half equal to 1. So your total spin multiplicity count by formula 2s plus 1. So it comes as a 3. So we call it triplet excited state. So your this figure B has triplet excited state, and for anti-parallel spin state, the spin s equal to plus half and minus half, it becomes 0. So 2s plus 1 becomes 1. So our spin multiplicity is 1 over here. So we express by saying that the singlet excited state. So your figure C represent the singlet excited state of the molecule. Now we will see the difference between thermal and photochemical processes. So as the word suggests, thermal means we have to provide heat to the reaction, to happen any reaction, to occur any reaction. And the photochemical processes means to happen any reaction, we have to irradiate with any photon energy which has h nu, so which is related to photon energy. So here the photochemical reactions, only a single selected species or atom or molecule can be promoted to excited state. So independent of the other species present in the reaction system. So that is the photochemical process. What happens in thermal reactions? So in thermal reaction, such they do not permit such selectivity. So thermal excitation increases in the random manner. So the translational, rotational and vibrational energy of all molecule resulting in excitation of all molecules to almost the same extent. So here all three types of energy, translational, rotational and vibrational energy get to the molecule, but in photochemical process only single selected species can be promoted to the excited state. So this is the first difference between two processes. So example, so exposure of mixture of hydrogen and bromine molecules radiated of wavelength between 450 nanometer and 550 nanometer. So if you irradiated with for this mixture hydrogen and bromine molecules, so that get result in excitation only bromine molecules in the that state. What happens with thermal reaction? So if you expose to the thermal radiation, that is heat, that would causes excitation of both bromine and hydrogen molecules. So both molecules, that hydrogen molecules and bromine molecules, start getting vibration. So all goes to in excited state. Now we will see one of the experiment, that is exposure of mixture of hydrogen and chlorine molecules irradiated of wavelength between 360 nanometer to 700 nanometer. So we will be irradiation will be red light, orange light, yellow light, green light, blue light and ultraviolet light. So all these six LED light we are going to irradiate, and we are going to see what going to happen to the mixture of hydrogen and chlorine gas molecules. Here I am going to demonstrate one photochemical reaction. In a closed quartz test tube is filled with 1:1 stoichiometric mixture of hydrogen and chlorine gas. We understand that hydrogen and chlorine reaction can be set off with light. So we are going to experiment with different UV visible electromagnetic frequencies to see what is the threshold photon energy required to reaction occur. We start with a red light. Don't see reaction. Now we increase in red light intensity. Still don't get any reaction. Now we got orange light. Still don't get any reaction. Now with moving with shorter wavelength, higher energy, yellow light. Still don't get any reaction. Moving with energy scale, now we get green light. Still no reaction. Now flash green light. Still no reaction. Now moving with blue light, no reaction. And finally with ultraviolet light, we see ultraviolet causes enormous immediate reaction. Here is the product form of hydrogen chloride gas. With humidity in air causes cloud formation. Now we are going to see the laws of photochemistry. So there are two types of laws are there in photochemistry. First law is the Grother's and Draper's law. It says that only that light which is absorbed by a system can causes a chemical change. So only absorption, whatever the light is getting absorbed by the system only that is cases to happen the any chemical changes. So that is the first law given by Grother's and Draper's law. So these are the two name of scientists, the Grother's and Draper's. The second law says that who is given by the scientist Stark and Einstein. So both are proposed one law, that is the second law of photochemistry, which says that one quantum of light is absorbed per molecule of absorbing and reacting substance that disappear. Only that molecules get absorbed light that only is going to react. So that is the second law, and only that molecule of the reactant will disappear. So this is the second law of photochemistry. So the second law of photochemistry was first enunciated by Stark in 1908 and later by Einstein in 1912. So here is the we come to end of this lecture. So these are the references for images, and for the content these are the three books a student can refer. So thank you for kind listening. See you in next lecture. Till then, happy learning.